Hi, I'm Richard, Principal at Quantitative Management Consulting. I'm here to show you a new way to use Excel that gives you way more power than you ever imagined. I don't mean some new tips and tricks. I mean a way that's architecturally different, that gives you 10 times the power for important problems, that gives you capability to handle large projects that other managers avoid, projects you wouldn't have dared to touch, but now you can. I've been a computer developer, development manager, and program manager of large development programs involving all varieties of hardware and software. I developed this methodology using these tools so that I could handle some pretty big projects. I call this Power Operational Intelligence. So the training in this channel will show you how to use Excel with other tools in ways you haven't imagined or maybe couldn't figure out how to do. These courses explain end-to-end how to put together tools for project management, my current work, or for other applications, particularly those with large logistics and operational content. Think of 10 times more power in your planning and executing a program, giving you deeper insight into how to predict, commit, manage, and report on a program through its life. You're not required to learn to code, but if you do, some familiarity with VBA, SQL, and pivot tables will take you even farther. Think of program management as putting together a focused company inside a larger company. The program manager needs product management to analyze markets in order to position product, development to create product, operations to build prototypes and later to ship product, marketing to get product into customer use, field support to keep products operational in customer hands. The program manager has to envision and create a plan, a prediction of actions, among all these functions and then execute the plan supporting business objectives like quarter spend and FCS and reporting regularly to a board of stakeholders. A lot like what a CEO does, only focused, more detailed, and with fewer people to delegate to. PMs know, they've been told often, they're the one neck to grab if anything goes wrong. These plans are quite detailed, involving technically explicit logistics for processes of design, build, integration, test, release, field use, and support, involving parallel paths through organizations within and outside the company. A credible plan for time and budget based on significant due diligence and in fact constraining the future is needed while much of the effort is still conceptual. The program plan reflects not just product requirements, but many more constraints: staffing, budget, compliance, legal, quality, and FCS target, to name a few. As a result of planning and then steering the organization through the plan, the PM develops an unmatched quantitative view of the organization, a view achieved by very few. Amazingly, there's not a lot of tool support for managing at this level. You get Project, Excel, PowerPoint, maybe Slack and Skype, and you're good to go. You have to develop tools for the program on your own. This is what PowerOpI is all about. PowerOpI provides you a handle during program planning and execution to exert leadership that's aligned from top to bottom and across the program organization. To be clear, PowerOpI is a methodology I'm teaching, not a product I'm selling. I'm showing you a method and working paths through common tools that you can use to link tools up front with data representing what you know about your project. Then you can use and enhance those integrated tools and data structures to predict or reflect your project as it evolves, producing coordinated views of the project, coordinated with plans for operation. Okay, here's an example product. Product is the enclosure at the center, plus assemblies within the enclosure shown to its left, plus software within the enclosure shown above it, plus software that provides functionality of the enclosure to server-based applications, upper right. Each team will have its own detailed view of the product. Hardware engineers will see metal to design, boards to design, based on chips and assemblies to build or buy. Software engineers will see software components that run the box, that provide intended function of the enclosure, software that connects the enclosure to the application. And of course, test. Each of these elements must plan for development, integration, test, and qual. Customer view is a little different. The enclosure is a functional part of an application, represented by a set of servers, switches, our enclosure, and physical support, all shown in the rack. So, of course, our enclosure must be developed in the context of the customer view. That means the program must include significant additional planning that includes many elements that are not within the product. Servers, NICs, LAN, many types of cable interconnect, switches, rack management. Planning includes identifying customer-like configurations, identifying specific parts to purchase, acquiring those items throughout the project, and building them for use. Project planning involves all the components, elements, assemblies, and integrations for the product, but also all the equipment to provide customer-like environments for development and test. Some basic planning logic. Sequence drives logistics, drives budget. Sequence includes the sequence of major tasks that must occur, dependencies and deliverables among them, task durations, and ultimately dates. In short, the schedule usually requires a few iterations to work out a plan that fits the required completion date. Both figures, hardware at left, software at right, are connected to the MS project plan and update automatically. Have you seen figures like this? Hopefully these give you some quick intuitive grasp of the progression of the project. There's a training module on how to create these. You can make them at any level of detail, high or low level view. And note that each bears a quantitative scrutiny because they're connected to the material plan and the financial plan, all driven by the schedule. The hardware figure at left shows some detail of development of a platform, with a sub-project developed slightly in advance of it. Material lead times, dependency management, plus financial management drive hardware development to the phase development shown. You might think of each phase as a giant sprint. There's a large degree of parallelism. Financial management is a large factor in hardware plans because prototype cost is significant and is budgeted at the start for the program as a whole, then again at each fiscal year, and reviewed in detail each fiscal quarter. And of course, technical sequence interacts with financial planning and creates spiky spending when protos are built that must be predicted and managed. The software figure at right shows the sprint sequence and shows dependencies and deliverables needed from one sprint to the next. Dependencies include some hardware and test deliverables. In my experience, 80% of program hardware is built for development and test of software, so it's important that the plans and execution of each are kept in sync. The tools and methods of PowerOpI make it possible to define quantified and synchronized plans. This OPI overview sequence continues in OPI Overview Part 2.